Hello and welcome everyone to OpenAI Meetup here in Cleevio. Today is a big day for Cleevio, at least, because it's first time in 15 years history of this company that we are opening our doors and doing some public event. Anyway, it seems like we are becoming less shy since we have at least opened our doors. But unfortunately today there will be not a single speaker from our side. It will be too much at once. For those who don't know Cleevio, we are a custom software development company where we are building products from scratch with more than 100 super talented people. And among our clients are companies like CNC, Deloitte, Prima, Superzoo. You can check it on our website. And end of advertisement. Anyway, most of you are here today because of topic that we have been hearing about for some time. And AI is here for decades, but we are experiencing something really unusual. Everyone is talking about AI. We see almost every day new product released based on AI. And maybe some of the companies, maybe some of the people are experiencing something like fear of missing out and trying to get a piece of cake from the AI hype around. But I guess that's definitely not your case and not our case, right, guys? And so I'm glad that today we can welcome our speakers who have been involved with AI for quite some time, and they will share their insights and experience with us. Sorry about that, but I'm going to read that since these topics are quite longer and it seems like it's the presentation itself. But Vojtěch Hudeček will be discussing whether the ChatGPT has truly revolutionized the AI industry, or if it is primarily a PR success. Petr Krejza will be shedding light on the transformative potential of ChatGPT and ChatGPT GPT 3.5 in revolutionizing human technology interactions. And Václav Košaš, sorry about that, will be presenting a comparison of symbolic and connectionist machine learning approaches. And also he will dive into the nuances of symbols, patterns, and hybrids. So let's welcome our first speaker. Vojta, it's yours, and enjoy that.
Thank you, David. Wow, that's a lot of you. So hi, I'm Vojta. I study at Charles University. I'm actually doing a PhD, which turns out to be a bad choice this time, but hopefully I'll finish soon, so it should be all right. My topic is, I would like to discuss ChatGPT from more like an academic perspective, that we can actually call it like AGI, autonomous artificial general intelligence, or is it more like a PR success and is thanks to good marketing that it is such a good success? And yeah, we don't have that much time, so let's get straight to it. So in case you have been living in a cave for the past 4 months or so, and you haven't heard about ChatGPT, so ChatGPT is some kind of a statistical model. You can think about it as like a magic box that takes some textual input and outputs also text. And this is actually a real-world example. So I just asked ChatGPT, write a first slide from a presentation that advertises GPT models, use bullet points. And this is what was generated. And I want you to just note a few things. It makes perfect sense. It's grammatically correct. It's a correct English. It's on topic. And it's actually factually correct information. All of this is pretty amazing. And a couple of months ago, we would be really surprised to see that. Now we just say, oh, okay, another GPT example. But it's actually pretty exciting that this works. And now I'd like to present these models in a bit of context and talk about how they are created and why they work. First, let me just recap a bit the past period. In the end of November last year, ChatGPT was released, and immediately it got huge public attention. Over the course of 6 months or so, over 100 million users was using it actively, and the number is still rising. Also, just a week ago, GPT-4 was released, so there's another generation of these models, and the pace of development is really quick. So you can imagine that in these conditions, to prepare a presentation is kind of hectic. It's hard to get all the information up to date, but I'll try to provide you with the latest insights. I want to note, and I will actually mention it a few times during this presentation, OpenAI is not the only company that can create such models, although currently it's probably state of the art, but there are others. There is Meta or Facebook that has these Llama models or OPT. Also, Google is trying to compete, and personally, I believe these models will soon catch up with performance of OpenAI models. So now let's talk about how do you create such a model. And the first ingredient you need is language modeling. So what is language modeling? A language model is some kind of statistical model, magic box again, that describes how likely is a sequence of words in some language. And I wanted to know is it doesn't depend which language. It can be also programming language or any language spoken on Earth, or even fiction language. That doesn't matter. What matters are the statistical patterns in the data. And language model kind of look at the data and learns the patterns. So it's best to look at the example. So there is one unfinished sentence, the best company is, and one word is missing. And what is the task of statistical model? It looks at the context and estimates probabilities for every possible word that could follow this unfinished sentence. And based on the highest probability, it would, of course, put Cleevio in the missing place. But in general, you get the point how this works. And it was researched for quite a long time in the linguistic community. So why this is so exciting now? Why are we all here talking about it? It's quite exciting to learn how to model language because it's quite complex communication system. But as I mentioned, it has been here for decades. And the point is, the size doesn't matter. Sorry, guys. This is how it is. And it has been shown that if we just train the model large enough, suddenly it starts to learn so-called emergent abilities or capabilities. And I want you to just think about the example of adding two numbers together. If you just learn language, there is no reason why you should be able to add two numbers together. But it has been shown that if your model is large enough, suddenly it learns it, at least to some extent. And no one knows exactly why this happens, where this behavior comes from, and no one really can control if this behavior appears or not. But it's just the fact that this happens. For context, when I talk about size, so these GPT-3 and later models are about 175 billion parameters. Parameters are just numbers. Maybe it's better to imagine in the amount of memory needed to store such a model, and it's roughly 800 gigabytes. So it's quite a big thing, and definitely not fitting into personal laptop or something. If you want to train your own GPT and use commercial services like AWS or other cloud computing platforms, the estimated cost is about $5 million, which is like not a cheap hobby to have. So that's why this is privilege of large companies to be even able to play with these models and trade them. So this is just an example, and maybe just focus on the first figure here, which is actually doing arithmetic, so adding and subtracting numbers. And on the x-axis, we can see the sizes of the models. And this is same architecture and same data, but if we just increase the size of the models, suddenly, after reaching some threshold of several billion parameters, it starts to learn the behavior, and it's like magic, basically. So that's one crucial ingredient to have model large enough and maybe train it for long enough time. Just to put it into context, in 2017, Google introduced the transformer model. This is actually the base for all these language models we use today, including ChatGPT. GPT actually stands for Generative Pre-trained Transformers. And this is some kind of model architecture. We don't have time to go into technical details. But the size was only about 50 million parameters. And over the few years, the sizes increased dramatically. I would say nowadays, this trend kind of stopped. Researchers try to focus more on using smarter methods and using more efficient ways of training. But it was important to kind of reach this threshold to learn these capabilities. So yeah, this is about development of increasing the sizes of these models. Another ingredient that was crucial was computational power, because if you have like this large amount of data and this large model, you need to train it for a long time on a lot of hardware that is very that has great performance. So the development on the field of computational hardware and components was also crucial to be able to even think about models of this size. Also, this is very related to the previous. Consequently, the price of using such hardware went down, and it's more affordable in general now. And last but not least, it's the amount of data. We as a society produce more and more data every day, and to train these models, we just need a big amount of data. So this also contributed to the development. So now we have data, we have the power, we have the techniques, and we were able to train large language models that has amazing capabilities, can do some reasoning, can do some arithmetics, and it's pretty exciting. However, this language model is kind of this huge, terrifying monster with a lot of tentacles and eyes, and it's kind of hard to talk to a model like this. You don't really know how to ask it questions. You don't really know how to get the knowledge from this monster. So what was the success of ChatGPT is that they successfully employed some fine-tuning techniques and put this little yellow smiley face on top of this horrendous monster. This is a smiley face. And in more technical terms, they created like an interface that allows humans to communicate with these models, and the models learned to follow instructions from humans. And that was like the breaking point when suddenly these models were, now everyone can use them, right? So this was one of the main reasons why this works. Again, sadly, I would like to talk more about technical details, but maybe we can discuss this later over a beer. But this was a crucial component to put in the mix. And one more thing, they actually don't pre-train these models only on human language. And as I mentioned, you can you can introduce it to any language. So they used a lot of computer code from GitHub and similar pages. And it has two big consequences. First, the model are ready to replace all the programmers, basically. It's not that simple, but they can write pretty good computer code. We have tried it for some homeworks for first-year students in the university, and it just passed with great performance. But there's also another consequence. It seems that if you use the code to pre-train these models, its reasoning abilities improves with the training. So because the computer code is very well structured and the ideas are expressed clearly when you code, the model seems to be able to leverage this behavior and improve its reasoning abilities, which is also pretty interesting. So this is all from the technical part. Now you can go home and train your own GPT model, maybe if you have enough money. So that's good. And now I would just like to discuss a few of my thoughts, my points of view on this, and I will be happy to discuss with you later if you have questions or if you disagree with me. That's why we are here. So first, business point of view. Actually, Peter will talk about this, I believe, in more depth and more detail. So I just briefly want to mention some things. Definitely, I recommend every company to use ChatGPT for internal usage. It can write emails for you. It can summarize meetings for you. It can help you with writing computer code, and a lot of processes just can get simpler and more efficient thanks to this. However, it might not be so good idea to put it in your product, and it really depends on the concrete use case. I have to admit, OpenAI models currently has the best performance available in the wild. They outperform Google, they outperform Meta, but this might not be the case for long. We don't really know. Also, the pricing is quite reasonable if you use it smart. However, there are some disadvantages. Imagine you build your product around ChatGPT, and it's nice, it works like a charm, but suddenly there can be some problems, like regulations of European Union with GDPR or something, and suddenly you lose access to OpenAI API, and your product just stops working. So it's good to at least think about alternatives. Also, some use cases are just like using a hammer to, I don't know what's the saying in English actually, but it's like asking a college professor to do math homework for you. It's just using too much power for too simple tasks. So for some use cases, this is just unnecessary to use it. And also, currently, these models are only available through APIs. So this means you need to send all your data and all your clients' data somewhere to OpenAI cloud. When they promise, we don't touch the data, but for some use cases, this is not really feasible. So there are some alternatives. There is Anthropic, which is actually a spin-off of OpenAI, recently sponsored by Google with a few $100 million. There is Cohere AI, models from Meta, Llama, or OPT, Palm from Google. Actually, this week, Google started testing beta version of its BART chatbot, which is supposed to be an alternative to ChatGPT. I think it's only available in the US and maybe United Kingdom, but things are moving very fast ahead, so it's good to keep at least track of some of the alternatives to this. Next one is science point of view. I spent quite some time in academics community, and I have to admit these models are just great. And I don't think many people expected. If it's just language modeling and some putting smiley yellow faces on top of that, you can obtain such good and mouth-opening capabilities. Also, we have to admit that OpenAI pioneered a lot of methods like instruction tuning, reinforcement learning of these language models, and they inspired a lot of the researchers to get excited and enter the field of AI. Also, they don't just focus on language models, they have also huge contributions in image generation or reinforcement learning of game agents, etc. However, quite sadly, basically, I think since GPT-3 was released in 2020, we should call it rather closed AI than OpenAI. They stopped sharing details about the training. They stopped sharing details about the data they use and the precise methods. And you can say, okay, it's their product. Okay, I can understand. But it was a nice habit in the science community over the last decades that all this work was shared and open. For example, when this transformer model was released back in 2017, Google didn't keep it as a secret. He published the architecture, he published the experiments, and it immediately transformed, by the name, it transformed the NLP community forever. And if Google didn't release transformer weights, there will be no ChatGPT, no GPT models. And that's just one of the illustrations how important it is to share and be open. And it was really a habit. OpenAI now kind of start to diverge from this habit, which I think is a bad thing. And maybe this is overthinking it, but I just think this kind of research is too important to keep a secret. No one, as long as I know, no one can really understand fully these models. These are like black boxes that we all use, and it should be open to researchers so we can learn more about them. And also, it's like setting a bad example, because now you say, okay, OpenAI doesn't share their models, so yeah, why should we share our training processes? So it's setting a bad example for the rest community. And yeah, we are approaching the end, and I just prepared like a comparison. And I want you to think about the distinction between humans and these language models. And also, you might then try to answer the question, is this really general intelligence? You can decide yourself, but I just want you to present some example. So for this, meet Stan. When Stan decided what to do, he went to Stanford. I don't know why. Now he's 25 years old, and he's pretty good student. Like he's in the Ivy League university. He's very smart, but he's a nice example from a human race. And let's compare him to train GPT 3.5 model. So first thing is the efficiency of learning. During his lifetime, Stan's body consumed about 20 megawatt hours of energy. To train GPT, you need about 60 times more. So it's much less efficient than learning a human brain.
But you can clone GPT and you cannot clone Stan, right?
Yeah, like you can make Stan a brother. But yeah, I mean, as I actually mentioned, this comparison is not entirely fair. And of course, there are a lot of arguments to raise against this. I just wanted to basically raise this topic. Also, if Stan is very enthusiastic reader, maybe he read 2 billion words in a lifetime, but probably much less. To train GPT-4, you need, or GPT-3, whatever, you need over 350 billion of words. Again, this is much less efficient. You need a huge amount of text. A human being is not in the lifetime able to even read this. So, the efficiency of learning is different. Next thing is doing arithmetic operation or logical reasoning. The GPT-4 that was announced last week, these capabilities actually improved a lot, but it still cannot be trusted with all the use cases. However, Stan is pretty good at math, and he can do these operations because he learned it at the university, and he can, for example, add two numbers with great accuracy, unlike GPT models. Next thing is that Stan can update knowledge in real time, and actually every one of us can. We listen to friends, to watch TV, read books, read internet, and constantly improve our world models. With GPT models, things aren't that easy. You need to either retrain these models, which is quite expensive, or you need to put new information in the context every time you use it, which is also like not that efficient and not a natural way to do that, right? Every time you need to tell the model the fact, you cannot learn it easily. And one more thing I want to mention is the expressing uncertainty. For human, it's natural to express that you aren't certain about something. You just say, okay, I'm not really sure how to solve this task. Let's ask someone that is more capable. But GPT models simply cannot do it, because remember, those are language models, and they always try to output the most probable sequence. So they just answer you something that seems likely, and in a lot of cases that's true, but sometimes it's just not true. And they cannot really decide not to do that and say, I'm not so sure, man. They just tell you some answer. So those are some of the differences I wanted to mention. Of course, just not to shame GPT-3. It doesn't get tired. Stan does sometimes, especially if it's out of copy, but you kind of get the point. Also, this can be fine. Like, it's different than humans, but it's not necessarily a problem. Because, for example, planes also use different mechanisms to fly than birds, and still we use planes, and it improves society, or it changed society. So this is not necessarily bad. I just want you to notice there is a distinction with human in kind of intelligence. And this is the conclusion. I think these models are really transforming the society. They offer exciting opportunities and use cases. It's all pretty new or very exciting, but there are some problems we should be aware of. And especially most of you as developers who create new products should think about it. Now, these models are hard to control, may generate abusive and harmful content, and so far no one is really able to control it with great accuracy. It's also advised to trust them with information access. Again, something I already mentioned. You cannot trust it that it gives you factually correct information. And last thing I will mention is the science, because it's kind of close to my heart. The development is just so fast at the moment that the scientists are not able to analyze what is happening, right? The research is funny. I mean, it's funny, but it's not. The researchers try to explain the behaviors, but we are not even close to understand these models. And maybe we should kind of sit back, take a deep breath, and analyze these models a bit first than before we put it in the wild and trust them with all different kinds of tasks. So I leave you with this, and if you have questions, I'm happy to answer now, or there will be QA session later, I believe. So please don't be shy to ask. Thank you. Any questions?
So it can be useful or it is not PR.
It can be useful. Yeah, but it really depends on the use case, too, for my opinion. For some things, this can be definitely useful a lot, but some use cases might just not be appropriate. Yes, as I mentioned.
What new job positions beside like prompting engineer, etc., do you think this will like leads to?
Yeah, it's a nice question. Actually, I think it will destroy a lot of positions, but it could also create new ones. For example, this can be like people who learn these models to behave correctly. And there is a lot of research potentially hidden behind this task, how to make these models follow the rules and don't be racist, don't be discriminating, be gender correct or whatever. This kind of positions, I think, are will possibly be created, for example. Yeah. Yes, guys.
How do you use it in your research?
Uh,
If you use it.
Yeah, I tried to do some experiments and prove that it doesn't work. Not so successful, but yeah, actually, I focus on research of dialogue systems, and GPT-4 is really new, and I almost did almost nothing. So I don't know about GPT-4, and probably it's better. But with ChatGPT for some task, it actually doesn't perform that well, especially if you have to have like a structured interface. So you need to access database or question some external APIs. In every turn in the dialogue, you need to communicate with some external knowledge base or something. These models can have problems to like, we don't really know how to connect them accurately to these APIs and how to leverage the external information. So in these tasks, it seems these models are not that great.
But actually, like Microsoft introduced the Copilot or launched the Copilot, and maybe it will help with work with databases, probably, if they have some special pattern.
Yeah, probably. I mean, it's still developing, and there are definitely ways how to do that. Just from my experience and my very limited narrow task, it's not a solution to everything, I would say.
Thanks.
Yet. Yes, please.
I'd like to ask two questions. Firstly, it's a statistical model. At the same time, you said that it's not very uncertain. Why? You can say that, well, I think that the probability is 62% based on my research. It's a statistical model and must know the percentage, the chance.
Yes, but this percentage is the probability of the sequence. It's not the certainty of the model that the information is correct. And it's like a small distinction, but it's important.
All right.
Thank
you. The other question, why do we have to feed it with a data set in advance? Why does it not search for on its own for new information continually?
Because it really cannot. There is no mechanism how to do this at this point. It can only accept textual input and output also text. And you first have to collect a huge amount of data and let it learn the data, but you cannot really do it online. Like actually, there are some research how to do it. Like the model will output, for example, a uniform resource locator, a URL to some web page, then can download the web page and put it into its training data. So it's possible, but so far it's not really a natural way to do that. Yes.
If you have a child at the age of first grade in high school, so what would you recommend in order to learn? Right? So the future is many things happen.
I don't know.
And they start farming or
probably farming.
rather than
I mean, it's hard to say. And there was this study last week, I saw it, that estimated that up to 20% workers on the labor market is currently kind of exposed to be endangered by these models. So, and actually the study mentions that the more money you make and the higher the entry barrier for the work, so the more sophisticated the job is actually more likely to be replaced. So don't tell him or her, but don't study too much, just do something with your hands and it will be fine. Yeah, I'm joking a bit, but it's really uncertain. Like this happens over the course of maybe 5 years from the invention of transformer model. So I cannot say what happened in 10 years. It's really, yeah, using a crystal ball.
2 years ago, I invented like 2 jobs that maybe will be happening. First one is therapy, like psychotherapy, like psychologists for artificial intelligence, because when they have a lot of data, they become like this, all the emojis and so on. And then the second part is kind of granular for AI, when they become bored. So when will this market be ready?
I mean, market for drug dealers.
Like it's the company, like one is the, let's say, psychological data provider, and something that you turn around. It's kind of a joke, but
I understand.
Thinking about it is not that much of a joke.
I think market is ready for everything at any point, right? The question is whether the society is ready, especially for psychology. I think it's unlikely that people, put their psychic health to.
It's not psychology for people. It's for the model.
Oh, you mean for the models? So you can treat the model to feel well and be happy. Okay. I'm not sure about that, but I think something similar will actually be a thing in a couple of months or years. As I mentioned in previous question, you should at least learn the models how to behave, and this is, I think, a real job that has the potential to be discovered. Yeah.
Have you
Maybe last question. Or okay, one question.
Okay, so I would like to ask about your research, because you said that you focus on the dialogue systems, and whether you focus on the short dialogues or also longer ones. Because when the ChatGPT was introduced, first tech journalists and other people from like tech industry, they tested it, and some of them had really long conversations with it, and it somehow fell into this kind of place where it adapted some personality, and when they tried to move on from the questions, it always took back and returned to the topic that was far sooner mentioned. So what's your opinion about this, and like the memory that this ChatGPT or these models hold, and it affects the further discussion?
Yeah, I'll try to answer the question. If it's not the answer, you can ask more. First, I focus rather on shorter dialogues in this aspect, and they are usually very well defined and have a very well defined goal. So basically, the task of the model is to reach the goal as soon as possible. So it's actually, we try the dialogues not to be that long in my area of research. And the thing you mentioned with long conversations is very interesting. I think an important thing to understand is that there is no memory. I mean, there is an illusion of memory, but those models always work just with the current input. And what OpenAI did is that they save your history, and they always put the full history into the model. So again, this is something about inefficiency, because you don't, before every response in the dialogue between humans, you don't read the whole history, right? You just remember it. It's not happening with these models. They always read the history from scratch. So there is no memory. It's kind of an artificial memory. And it just depends how big the context window can be. And then the models are seem to be able to pick up the information from the context pretty well. So I hope that answers your question.
Yes, it does. They actually then change it to not allow that long discussions or chats.
Yeah, it also has to do something with the computational efficiency, actually. They have to serve a lot of curious people asking these models at the same time. So by making the context window smaller, they save some computational power to serve more people. So I think that's one of the reasons why they did it. And maybe the last questions later we can.
Okay, so last week I was talking to a student of teaching Czech language, and he was super overwhelmed regarding those models.
Mhm.
And he asked me, like, because his students already use ChatGPT or GPT to write essays. So he asked me what would I recommend him, how to detect whether they really wrote it or not. And first I told him you can use summarization, you don't need to read that. But also, yeah, how would you say to him, like, how can he or she know whether human or the model wrote the text, except for saying, okay, if the human uses, like, I don't know, bad grammar for something and it's not there, maybe it's from the model.
Yeah, it's a $1 million question, I would say. Soon after it appeared back in November, people were asking this exact question. Actually, some group of scientists try to develop models that detect this. So it's given a text and it will decide whether it was written by humans or GPT or similar model. It can work to some extent, but I believe as these models will improve, which they will, and they are every second now, basically, this will be very hard and almost impossible, because it just picks up the information from the training data so well, it just mimics people, and by definition, it's kind of hard. If you bring this task to perfection, these models, it will just not be possible to decide. I think the psychology actually can help here more if you know the student and the text is suspiciously good. But yeah.
But you can say in prompt, use some like mistakes in the grammar or something.
Yeah, you can do that. I mean, there can be artifacts like some say that people don't really use, and ChatGPT uses it, and by this you can try to detect. But again, as these models will improve, these artifacts will be present less and less. Yeah, it's kind of a question what to do with education now. I don't have the answer. So yeah, I don't want to steal more time from my colleagues. Thank you all for.
By the way, there are a few more spaces here. There are three more spaces here. Someone wants to sit. Okay. Hello. Maybe let me add to what Vojta was answering. There was one question about what would you recommend to your kid? Like, what would be recommendation. I have 12 years old daughter, and I can say I can recommend anything I want, and she just ignores it. So it's probably the answer. My talk will be more from the business point of view. I had to shorten the name of the presentation because at the beginning, if you saw that like super long text, it was obviously generated by GPT. My name is Peter. I work for Amplify as a researcher, mainly focusing on the NLP tasks. There's a couple of very clever people on the team. Not so important about company, but we mostly process social media data. So working with the kinds of social networks. And around the social media, also my talk will be mostly about applications in social media. Because like in our product, clients can pretty much work with their social media profiles. They can publish posts, they can analyze the competitors and so on. And pretty much in each of those bullet points, you can use some AI, either some predictive models or some generative models. So I'll be talking about. Yeah, about the team, a couple of people here in Prague, in Posen, in Brno, and a few more in US. As I said, we mostly working with the social media data. And regarding the projects, it's pretty much everything: NLP, computer vision, some anomaly detections, and so on. Okay, let's start with the talk. Oh yeah, as I said, I'm coming from the world of social media. So let me start with one quick question. Basically, whatever is your preferred or most used social media network, Instagram, Twitter, LinkedIn, can you guess like what is the percentage of ChatGPT, GPT related messages on your wall last week or month or something? I'm just curious. There is no like right answer. I have number for myself, but 60. Okay. Somebody more? In my case, on LinkedIn, it was like, I would say 105% or something. Everybody. And I have people from marketing and from research community. Everybody was talking about GPT, and everybody is expert on GPT last day. Only if your preferred network is OnlyFans, you probably haven't heard about it. But you might hear about generative models very soon, or generative content. One thing we work on recently in company is a tool called AI Composer. It's basically GPT 3.5 interface for social media marketers, so they can create their own or speed up creation of their own social media posts. So basically, you can put like super short prompt, and with some configuration, the AI can generate a couple of potential new social media posts. So they can choose whatever they want, edit it, and publish it. Because the primary goal is to speed up this process. There are some clients that are publishing tens or hundreds of messages every day, and they are very interested in it. So we added like pretty much all those cool features that GPT offers, like changing the tone, making it more happy or more sad, or even some crazy tones like Shakespeare or Yoda. But apparently it works, and Shakespeare is not in production, but marketing guys love it. They are presenting it every day. So this is something we built, and it was like super quick action because GPT 3.5 was released in end of November. So we were able to have like first demo in early December. Then because of Christmas and some like slowness on the engineering side, we were able to release it in February. And it got like quite interesting media coverage because we were first among our competitors to have something like that. It's more like, in this case, it's more about the PR. Yeah, and immediately after that, pretty much everybody in the company started asking, we would like to get more of NLG or more of GPT, more of ChatGPT. So a big part of data science team basically was right. Hello, don't hello. Okay. Change. Don't change. Okay. So some part of the data science team was converted to prompt engineers and were playing with the GPT prompts for quite some time. And from the day one, there are like a lot more use cases. Companies and clients are interested in. Summarization is one of the things where GPT or similar models are quite good. So we can do. There is a discussion between agent and a client, and we can summarize the text in a couple of bullet points, because then they can use it further. And probably one of the, or at least for me, one of the hottest topics on GPT style is how to combine generative capabilities of the model and the knowledge base. So this is something we'll probably see more and more. There are two options. None of them is great. First one is fine-tuning the model. OpenAI allows it for some of those models. It's not so cheap. It's not so great, but it's possible. The other thing is more like the combination of traditional search and NLG capabilities. This is probably the way we will go in the future, but also, yeah, I think I'll skip the architecture because we discussed it for quite some, at least a little bit. And if you are interested, take a look at least at those papers. What is important is that reinforcement learning, that was the breaking point when it really started working. And you can always ask GPT to explain it, like how transformer works. I typically start, as I mentioned, I have 12 years kid. So I typically, my prompt is explain it as to 12 years old kid. If I get it, which is not always the case, I can move it to explain it as a high school student and so on. Yeah, let me talk a bit about how we onboarded the surveys, because I work for a corporation, so it's not so not that easy that I can register for OpenAI account in the evening and play with the demo and have application. Obviously, there are a couple of more or less strict rules, and from the very beginning, Vojta mentioned a little bit. OpenAI was originally founded as a non-profit organization. I would say it's no more true. You can see some of the names that were at the beginning. I believe Elon already left, and not sure if he is happy about it. So I think, yeah, he would probably need some money for now for his experiments in Twitter and so. But OpenAI is relatively small company, just a couple of hundred people, and they work not only on GPT, but again, they have solution for images, DALL-E and Whisper, which is speech to text solution. Cool stuff. And recently they got super big investment from Microsoft, and that's why you can see OpenAI technologies being integrated into Azure and Bing and all these Microsoft things. Regarding the onboarding, typically, again, in a corporation, I'm getting on a daily basis emails from sales. Hey, we have super cool product. Could you let's hop on the call and we can explain it to you, possibly sell it to you. I typically don't answer, so they repeat it every day and then a couple of times. OpenAI has, they have different strategy. So I was not able to talk to them at all. I contacted them maybe 5 times in the support team, sales team. No answer yet. Probably we were not so important as a client. So it was a little bit, stressful for me before we launched the product, because like the only interface was their web and some settings, how many dollars you want to spend per month, and also like the site is not that super reliable for the APIs. You can see this is just like one of the screenshots I can have. Like I can provide many of them. If you register for their status page, you are getting these emails pretty much every day, like some outage or partial outage, sometimes major outage, sometimes everything is down. So, it's again a little bit frustrating. I wouldn't build like product or project fully on OpenAI, and you can see the uptime pretty much like a couple of times a month. There are some outages, so also like be careful here. What is also funny, at least for them maybe, they continuously upgrade the models. They typically don't inform you. So if your prompt works today, it doesn't mean it works tomorrow, or there might be some small changes. It's typically more or less work, but not for 100%. So this is a little bit tricky. They offer some snapshots, so they promise they will keep some of the snapshots for 3 months. But that's it. And also, we talk a little bit about it. Those models are not fully deterministic. There is a parameter for the analogy models called temperature, where you can basically derive how creative these models are. The higher temperature, more creative. But even if you set temperature to zero, you don't often get like same answer for same problem, same answer. So this might be a complication, depends on your use case. And because we are a big corporation, everything is driven by law and security. OpenAI, they own, you need to follow their own terms and conditions, because they are relatively strict. What you can or you cannot do with your OpenAI, you cannot generate harmful content. You should not generate political campaigns and so on. So pretty much, if you want to use their products, you should be compliant for them. The screenshot here is from something from a document we called Data Impact Assessment. It's another like bureaucracy around you need to fill, and it's not just case for OpenAI. It can apply to all language models, because like as soon as you have a product built on the model, there is somebody who is going to ask, how are you dealing with gender bias in your models or in your data? So a lot of questions. For many of them, you don't have answer. But you need to be ready to at least describe and maybe accept those risks. Okay. Pricing. Vojta told how much it costs to train the model. Let me look at it from the point of view how much you need to pay if you want to use OpenAI. They typically charge you according to number of tokens you consume. Roughly, we can say that 1,000 tokens is about 700 words, 750 words. So in the case of GPT, it's like 2 cents for 1,000 tokens, and they charge you for input for your prompt as well as for the output. So if you send there like super long context, you are charged for that. GPT-4, which is now being available, it's not yet ready for like production usage. It's for the completion. It's about like 3 times more expensive than GPT-3. On the other hand, ChatGPT conversation agent is a lot cheaper, but you typically send a lot more data there. And you can also use embeddings. They offer, they are super cheap because you can have millions of models generating embeddings for your sentences and for free. And one good thing is they also offer a moderation endpoint. So if you potentially, your prompts might potentially contain some, say, root words, toxic words, this endpoint can flag it, and you are at least a little bit complying with terms and conditions. OpenAI API is, as I said, quite okay for small loads. But if you are talking about something bigger, and one of the models we have in company is for sentiment analysis, with that number of predictions, around 40-50 million a day, the biggest model OpenAI has, which is DaVinci, it would cost us like $10,000 per day, while the regular solution, which is partially transformer, partially some recurrent neural network, is about $50 a day. Not even talking about speed. So there might be a big difference. And differences. Maybe one more question. We haven't talked about it much, but do you know the difference between ChatGPT and GPT-3 or 4? Super quick.
Amount of the training data.
It's
Name, brand.
Reinforcement learning from human users.
I think both of them are using that, right? Just ChatGPT is probably smaller, more focused on the context. But I wanted to show that for us, yes, there might be a difference. For the rest of the world, meaning maybe 99% of population, there is no difference. This is screenshot from Google Web Trends, and it compares how people are searching for ChatGPT and GPT-3. And you can see like nobody searching for GPT-3. Like, nobody knows it. For pretty much everybody, ChatGPT is the only solution. They are mixing both technologies, and I am kind of on a mission last 2 months, pretty much on every day. I'm trying to explain to somebody in company the differences, because like marketing was able to generate marketing news or PR news about how we are using ChatGPT, and it's not true because we're not using it, and so on. So people really don't see a difference there. And ChatGPT is everywhere. I don't know if you are a fan of South Park. There's one of the latest episodes. It's full about deep learning and ChatGPT. So a couple of use cases there. If you want to get some inspiration, definitely recommend watching the episode. So as I said, or as we said, originally GPT-3 went out in June 2020. They have a couple of models. DaVinci is the biggest one, most parameters. Ada is the smallest one. If you want to use generative capabilities, definitely DaVinci. But those smaller models can be used for classification if you want to have your own sentiment analysis and fine tune the model. That's possible even with the smaller models. Then in November we got GPT 3.5. That was the milestone. Yeah, and as we said last week, GPT 4 is rolled out. We have access for the text stuff. It should be multimodal, or they say it is. It should be able to read images and work with the images, but it's not available yet for public. And all these models, I think they are using still same data set, which ends in 2021. context is something quite important for some of the applications. It basically says how much data you can send to the model, how much you can put into memory, it flows. And GPT-3 started with 2,000 tokens, which is, I don't know, not so much. And you can see it scales up. And like the biggest GPT-4 is not yet available with 8 or 32,000 tokens. You can really send almost 50 pages of text to as a context. So it can summarize pretty much, I don't know, half of the book or like chapter of the book. Some people were playing with it and doing the summarization of Lord of the Rings. They run summarization of each chapter and then summarization of some of the books. And it works very well. These numbers are from are statistics from dataset used for GPT training. You can see that the vast majority of training data is in English, and the rest is around 1% and even less. In Czech language is 0.07. Surprisingly, it works quite well for the non-English languages. And it understands Czech, it can generate Czech, you can prompt in English and ask to generate in Czech and vice versa. It's not so great as English, but it works surprisingly well. So there are, like, I would say 20 to 30 languages where you can use it pretty much out of the box. Here is one example. So social media. My prompt was in English, generate social media post in English about following text, use English hashtags and emojis, and context was in Czech. It was a slon, havárie, auto, všichni v pořádku. It's my favorite example, I'm using it on every day. Basically means elephant, car crash, and everybody is okay. And you can see that it works pretty well. Although then in the second example there's one small mistake. And by the way, it's GPT-4, like the second example. It did not translate slon into elephant, but it knew that it's elephant and it put a lot of emojis of elephant. So even you can really mix it. And this use case might be or is definitely interesting for some of the clients because they can write their prompts in English and generate the output in Spanish because they have customers in Spanish. Okay, are there any other alternatives to OpenAI? Is there anything else you can use? So first alternative is in OpenAI, still in OpenAI, but it looks they started offering as a service that you can rent your own GPT on dedicated machine. The price is okay, starts with $20,000 a month. If you are like super big company, probably can afford it. Small company not yet, but if you compare it to a few $1 million used to train the model, it's not so bad. So first alternative is OpenAI itself. And then I would recommend this web page, not.dev. It's a comparison of roughly 30 different models, and you can basically send your prompt to all of them at once. Not all of them work every day, but you can see that. You can see the response. There are almost all OpenAI models. I think there's Elevator AI, something from Google. So it's very good page to take a look. So I sent my favorite prompt there. Again, generate social media post for Twitter about the car that crashed into elephant, but it was happy accident, nothing happened. And I sent it to pretty much all of those 30 models. It wasn't great all the time, and we can demonstrate some of the issues these models typically have. So first model, that's not even sure if it would work. And this is not just copy and paste. Typically, it's happening quite often that these models basically start repeating themselves and they generate some sequence again and again. Second model was slightly better. By the way, I'm not adding the names of the models here, just not to blame the authors. Second model was slightly better, but it also doesn't understand what does it mean add hashtags and emojis to my prompt. Actually, it added hashtags and emojis, but not the way I wanted. I like this one. That's for surprisingly philosophical. I wasn't able to use it, but I had some nice moments with the model and more. Yeah, and this one I add a name because it the response was what I was kind of expecting. So this is the model from Anthropic, probably one of the biggest competitors of ChatGPT. They are more focusing on some bias reduction principles, and we'll see how successful are they. I think they released Claude last week as well. So there is a sign-up list. If you are interested, sign up and you might get access. Yeah, so you pretty much mentioned it. Claude is ready. Google Bard was released yesterday. It's available for UK and US. Llama from Meta. It's funny. There was some waiting list and only for researchers. Then I think weights of the model somehow leaked to Discord. Now everybody has access to a couple of Llama models. So if you want to train your own, it's available somewhere. And we are almost at the end. I just wanted to show a couple of examples or a couple of companies that are doing a lot of energy. These screenshots are from OpenAI. They have examples for many use cases you can use OpenAI models. So there's a classification, there is a summarization, and so on. I would say almost for each of these items, there can be a company built on top of this, 5 lines of the code and start selling it as a product. It's like quite hot area. But I would like to mention a few of them. One is Jasper.ai. They can help you creating the content, blog posts, social media posts. Relatively expensive, but I would say valuation 1.5 billion for a company founded 2 years ago is not so bad. And it looks they have enough money that they are even thinking of partnering with one company, with one hardware company, and training their own GPT solution. So yeah, with this valuation, with these investments, you can probably afford it. So Jasper.ai is definitely an interesting thing. Copy.ai is similar. They are much cheaper. Again, there are multiple various templates. You can have templates for blog posts, for emails, for whatever else. They have like 50 templates, and it works very, very nice. Duolingo. I don't know if you know this application. They have currently Duolingo Max supported with GPT-4, so you can explain better some of your answers. And again, lots of looking. And what I'm really looking for will be the integration into Slack. So Salesforce said they are going to integrate it, and so you can summarize some threads, you can draft replies. So this will be quite interesting. And the last thing is also application called Speak, and they are combining Whisper, which is speech-to-text solution, with NLG. It's like nice combination. Okay. And few more slides related to not recommended use cases, because like so far we are talking about these like positive ones, but not everything is so great. So I wouldn't probably ask GPT-3 to generate password for me. It might work, but I don't know. It's a good idea. Second and third point. Second is definitely related to almost all neural networks. It's relatively difficult to explain why this was generated. And last point, hallucination. Hallucination is something that was heavily improved in GPT-4, but still it means these models can sometimes generate factually incorrect answers. So if you don't help it and you ask, I don't know, when is going to be next meetup in Cleevio, all of this probably nothing planned yet, they would answer, I don't know, next week on Tuesday, 6 p.m. And it might be very confusing for people. If it's not true, sorry, I don't know. One more question for you guys. This is like old developers, programmers joke. So if the code you wrote last sprint would be used on the plane, would you join that plane on a flight? Who would join it? Nobody? No? I think I would say it's safe because like if I would let go, the plane probably wouldn't even get off the ground. So it's safe. This is in the past, but like I would paraphrase it here. Like if GPT-3 or ChatGPT recommends you some medication, would you take it? Because like difference to, I don't know, 5 milligrams and 50 milligrams or 5,000 milligrams is not so great, not so big for language model. For you, it might be, you know, life experience. So really be careful here. And regarding the data, again, garbage in, garbage out, as like everybody knows about it. GPT was trained on a lot of data. There are definitely Wikipedia, maybe New York Times, but there are also less reliable sites like Reddit, for example. You can find a lot of interesting, facts there. So again, it can be a little bit difficult. And one of the examples I have with the Muslims here, I don't know if you remember when GPT-3 started, there was people immediately started hacking the prompts and make it to generate as much as an inappropriate content as possible. So typically there was like 2 Muslim men walked into a bar and GPT started shooting or started something like that. So and you can exchange Muslim with 2 Jewish men or black men, white men, doesn't matter. It was always very, very interesting. So this is something that is still happening, although GPT or OpenAI is probably doing a lot of stuff to mitigate these problems. But if you are using other models, you might see a lot of these. And by the way, I recommend you to try these prompts to see how they solve it. Even better prompt is like 2 Muslim men walk into a synagogue and with axis, and you'll see what GPT replies. Last slide. Summary for me. Definitely this world of GPT or generative models is fascinating. It can really help you. No, it's not conscious and there's no like intelligence there, although it might look like. And if you use it as a powerful assistant, it can help you a lot. It can incredibly boost your performance. I'm not sure if it was Andrei Karpaty or somebody like that. He said it is like 80%. So like these tools can give him 80% of his code, so he don't need to write all his stuff around, but he can focus on the important parts, similarly when writing. So it's like really as an assistant, you are responsible for output of your assistant, but it can help you a lot. Thank you. Any questions? If you have time.
You mentioned the data set that was used for training the GPT models. How much is it known about the data set?
I think quite a lot. There is some GitHub page. I don't have it right now, but if you Google it, you can find quite a lot of it about the data set. Statistics, like how many documents work, and also like what's really there, like percentage of Wikipedia. So data set is probably not such a big problem.
Okay.
Theoretically, it also might contain some copyrighted data, which is another potential legal issue if GPT can generate copyrighted data. Nobody knows how to solve it, but yeah, that's how it is.
And just one question, you said like Google it. Do you think is there gonna be a word for ChatGPT?
GPT is or Bing is. We'll see if like implementation in Bing is good enough. But I think there'll be like more of these GPT style search engines. We discussed one of them. It's called u.com. It's also like general search. Yeah, we'll see. I think like in company we have a couple of US folks, and they really love these shortcuts and how to say. So there will be something very soon, I believe. Okay, thank you.
Short 1 minute break. I now work for Glomin. That's a professional search engine which connects customers online to e-shops, and we have a huge catalog, 10 million products. And what I do there is that I develop a machine learning system that each month processes around 40 million products and detects features in them. We also recently, if you're interested in machine learning, we also from time to time publish some resources which you can experiment a little bit. So for example, recently we published this data set and a pull-up notebook which you can execute online on GPU if Google will give you one. And you can actually on this data set you can play with combination of texts which are in multiple languages and images, and you can see how the text corresponds to the images, and if you can classify the products, if you can find similar products with just using images and so on. So you can try that as well. And today I would like to tell you what is increasingly becoming popular with the large language models. What I think will be a future of the field that could potentially provide some things I think are missing for us perhaps to get to the artificial general intelligence as defined maybe as a system that can do as many things as, for example, person in 2022, average person in 2022. And okay, so what are the missing things in the current systems? So now we sort of burn through, gajillion, it's like trillions of floating point operations, like we do all these multiplications, and we still get hallucinations, and we still get quite poor reasoning capabilities. And there are approaches reducing this, but something still seems to be missing. And yes, it's true that humans as well, hallucinate. For example, you may have false memories, or maybe you don't remember everything perfectly. For example, if there is a crime, oftentimes the people have actually different accounts of the accident. But we already developed approaches how to deal with these issues. We write down symbols, and into the symbols we can even encode rules. And the rules can operate on the symbols, and it's like a perfect system. Like, it was super successful in understanding the world because we used it in mathematics, we used it to do accounting, and as well because we can write things down and they don't disappear, they stay the same. Like, it's an immutable storage. We can also think about it, think about the things multiple times. And another thing, like perhaps it's also important, is that we can act in the world, and so we can sample new data and can learn new things from experience. And these successful approaches were then later used to develop computer programs, which are also rules, which operate also on some symbols. So the same way we actually built these computers which take something that's crystal perfect and it can produce something that's still crystal perfect. And while all at the same time, this seems to be missing in the language model. That this sort of aspect is not quite there, and so again, what are the differences between the systems that we have? Now we had two presentations that taught you what we have now. It has great capabilities. You can use it for many things, but it has also issues. And so, if we can compare what I'm talking about, these symbolic approaches that use these symbols and rules, with what we have, which is like dominant result in current time. So on one hand, we have these symbols and rules, and on the other hand, we almost have something like feelings and intuitions, something that is able to find patterns in huge amounts of data. And on the other hand, it's something where we can put in, after lots of work, we can put in some great rule set that will work. And it will work so well that it doesn't matter how big is the input. You can like in maths, like you can take equations and you can input an x, and the x can go to infinity, and the equation will still work. It will still be great. While in the neural networks, this is not quite possible. You have always some kind of limitation. So always you are somewhere between -1 and 1, and so you can't really do something like this. And so, as I mentioned here now, these large language models are neural networks. So these neural networks just take some floating point numbers, and they do some matrix operations, maybe a couple of extra operations on top of that, and they produce vectors, like these arrays of numbers. And that's what is the inner representation of the model. That's sort of what it feels, and if it changes just a little bit, then it's like it thinks about a very similar thing. While on the other hand, in the computations, we have the hard symbols, and that's a very different thing. Also. In the symbolic domain, we have these instead of neural networks and gradient boosting, on the side of the symbolic approaches, we have these decision trees For example, you can see one here. So where you operate only on this very interpretable inputs that come in at the beginning. And so those are super understandable, they are simple, and they have the different capabilities on different types of situations. And so these algorithms, these computer programs, these rules, were actually used to be, it was a dominant approach in machine learning, in artificial intelligence in 1980s. And it seemed like this is going to work. Right? We are just, AGI is just around the corner, right? We are going to have it like tomorrow. And suddenly there started to be issues. It wasn't progressing anymore. And so what these systems were doing, what was the approach back then, and why it collapsed? So back then, the approach was that you would have even like dedicated hardware, right, the one on the right, and you would write for your problem. You would collect a group of experts that would understand the domain. You would also have the programmers that would be able to actually write the rules. And over some time, you would build up the system, and it would actually work in some cases. And but it was expensive. It was very hard to update. If something changed, it was kind of a brittle. And also in some domains, if you think about it, the experts don't actually really know what they are doing. They don't really know why they are doing it in this case this way. There's sort of this tacit knowledge, which is more, it's sometimes maybe like beyond words, or you would have to construct some new words, and maybe you would have to have something soft in between the words, between the symbols. And so while everything seemed great, the solutions were not able to get to the AGI. The dedicated hardware companies got into big issues where the hardware changed because there were new, more general systems, and also the different sort of approach that was leveraging neural networks, relying on the more general hardware, more powerful hardware with more data, was starting to get traction, and so this was mostly an abundant approach. And then here came the neural networks, and there Hinton, researchers Hinton, LeCun, Bengio led the neural network revolution in 2010, and this approach became so pervasive that, for example, people were saying deep learning is just going to solve everything. Like, this is it. It's we don't need symbolics. This is going to just solve everything. And so people started to use neural networks. They were using supervised learning, where you have labels, so you know what is the target. And in that case, there was this breakthrough in development of AlexNet, where suddenly it was possible to classify images with very good accuracy on this popular data set, which, before, how would you actually describe rules for images? Like, how would you recognize what's in the image by using rules? It seems rather difficult, and it is. Like, it was possible, it was being done, but it's like very difficult and very brittle. Then over time, there were also studies of language, and people started to build these statistical models of representing words as these vectors, as this array as floating point numbers. And for example, in 2013, there was a paper published in which actually one Czech researcher called, his name is Mikulov, she participated in the research in a major way. And so this was the approach where you represented each word as one vector. Then over time, 2017, transformers where you could understand the entire context, where you input multiple words, you would actually understand sort of where you are in this space, not just in case for each word individually, but suddenly you were in some thought space that had many more dimensions, and it was possible to get good results with these. And people started predicting next word in web scale data sets. We started getting interesting results. And now we are just in the situation where where we also implemented this reinforcement learning from human feedback, where we started hiring experts, and we are starting to get dedicated hardware, and like suddenly like it sounds, and AGI is just behind the corner, right? Like it's just there. Like I mean, there may be some similarities. Is this really the final approach? Or is this connectionist? Is this the final answer, or do we need to add something more? And so regarding this reinforcement learning from human feedback, that's actually a very interesting approach. It's not quite the same as before. Now the experts don't have to actually write some super complicated thing. They can review the text. They can say, okay, this text is better than this text, and they don't. Their result is not like too small for one case. They actually get a bigger lever, and they have much bigger impact. So this is much more cost-effective approach. So it's not the same situation. They are in much better situation, of course. And as well, this I spoke about the hallucinations. They are also improved with this reinforcement learning from human feedback. But we will see that you can get much more, like these other approaches of using symbols and being able to actually these very scalable approaches of the algorithms and code. That's like so useful, and it seems to be so missing that it's definitely going to be applied. So what I think will be necessary and what's increasingly being applied is hybridizing both of these approaches. So also using both neural networks and symbolic approaches at the same time. So actually the language models already use the symbols. They use symbols as their input and as their output. So they are a combination a little bit in this sense, but we can go much further. We can, because the inputs are symbols and outputs are symbols, we can plug in the systems that we know. We can plug in the algorithms. So, for example, one of the most simplest way where you can start doing some sort of thinking inside of the language models is when you guide it with the prompt. It always tries to predict the next word and go to the next word. So you can sort of guide it by telling it by writing into the prompt. Okay, so before deciding this, let's think step by step. And with this, you will actually get improvement immediately. So you are already like giving it this multi-step process where it can iterate in some algorithmic way, and you get better results. Also, another approach is this self-consistency. So you combine again this language model with the approach there where you request multiple results. In the paper AlphaCode, they produce many code samples, and then they they sample from such samples that cluster together. They are very similar, and from the places where there are lots of similar samples, those actually it works great if you sample from the biggest one first, the most. And another approach, very recently, it's called toolformer. So this, again, we know that the language model can take in, sees the past, and it can predict the next token. So what if it learned to exactly call something outside, but not in some template way? Of course, you can do templates. You can like ask question and then you wait like what kind of output can be here. It has to be name. Just give me some kind of name, and that's the right output. But instead, here you can have it like freely learn to ask at the right point. So, for example, if there is a question of for some sort of calculation, and it sort of it writes down some continuation, some text, and you can with a rather small training set, you can teach it to call calculator function, which it can use to do the calculation for it. You know, maybe it's not so good in doing the calculations, and it can learn to call something external. It will get the results as well into the context. So instead of predicting the output, it would get the output from the model. It would sort of stop predicting for a couple tokens and get the result. And using this, you can improve actual performance on dedicated tasks for that can use calculator, that can use some question answering from Wikipedia, and so on. Now, multiple other approaches. For example, searching. So if you heard about this AlphaZero, where you have this chess playing engine which gets superhuman. How does it do that? So it does learn from playing against itself. That's a very important part. But also the space of all the possible actions in chess is too big. It cannot go through everything. It has to go somewhere where it's interesting. How can you do that? Again, you use neural guided search, where the network serves as an intuition, and it can sort of think about, okay, now I'm in this position, and I think I could do this. This sounds good. I could play this, and then it can, with self-play, sort of go further into the direction. It can evaluate and learn using this approach very effectively, and it becomes superhuman. Then there is this retro transformer. So that one, instead of just having everything stored in its parameters, it actually stores as well the database of the training set, and it can retrieve on demand everything it saw during training. And of course, you know Bing. It can generate queries on the internet and can give you the right summary of what you are asking. And now I wanted to mention Dream Coder. So this is a super intuitive idea of if you wanted to solve some complicated coding problem, how do you usually do about it? You usually use lots of libraries, and how those libraries were created. So this approach actually learns to build its own function library. So in first iteration, it solves a couple of simpler coding problems. Then it stores the programs it found. It sort of analyzes them very quickly using algorithms. It then finds what are the most interesting functions to remember, and it stores them in the library. And once it has new functions, it suddenly becomes easier to solve the other problems. So this one combines the search and the memory of building this library to solve coding problems. And you also may be asking about how do you integrate images, and you can do that as well. You have the image can be broken down into patches. You can detect things in the patches, and there is this recent paper, GPT, which can reason on images by it gets a question, it generates code that can answer the question on the images, and then it does sort of a calls on the image using this code. So it can count how many muffins there are in the image. So it synthesized code which then calls detection of muffins, and then it just sums how many of them are. So if it can detect the muffins, then the summation is like simple. Like it's mathematics is like super simple. I have the code, like it's couple instructions. It's not trillions of matrix multiplications. And for example, Jan LeCun was big on connectionist approaches. Now, recently published augmented language model, which is an interesting survey of these approaches. We can have a look at it as well. And also, if you wanted to really, people are also asking like, how exactly is the GPT bad? Like, can we find some set of problems on which the GPT completely fails while humans do great, right? If you want AGI, you want to be looking for something like this. You don't want to be having 100 tasks that's not interesting. If you go to AGI, you have to have something like this. And Zadražil developed a data set on which GPT 3 got 0. I think GPT-4 it's not evaluated yet, and they are developing for the models, and can read about that as well. And of course, like OpenAI must know about this. They are very good at listening. What are the problems with their system? And right now, what seems to be their view is that this reinforcement learning from human feedback will solve most of the problems and will actually get them to AGI. So they have smart researchers. They know about this, but they think this providing these expert answers and comparing will get them to AGI. But at the same time, like they are aware that they cannot scale it infinitely because this perhaps not enough. Because this reinforcement learning from human feedback, it requires the researchers. The cost for the researchers is still not as big as the training right now, but it's getting harder. Like as the model gets better at the tasks, it gets harder to evaluate the results. And so now they are thinking about using the AI to assist this reinforcement learning approach, to help those experts to do the review. And it helps, this approach helps. It's again like iterating, it's critiquing itself, so it gets some task, and then the machine produces the answer, and then criticizes the answer, and then tries to improve the answer, and it displays it all to the evaluators, and the evaluators point out even more problems when they get this input. And so the idea would be eventually to have very minimal input, and the machine would be sort of through self-critiquing, getting better and better with less input. So giving even even bigger lever to the experts. Okay, so if you wanted to learn more about this, there are companies and people which publish things in this domain. For example, on Twitter, that you can follow Gary Marcus, you can follow Zadražil, and other authors of the papers. Also, what I found interesting is that here in Prague, there is also this startup called Filter.ai, which they are even explicitly thinking about composing AI. They call it composite AI, where they want to use planning combined with that, with algorithms that can detect provide this, convert from this soft input into some hard symbols and then do planning for companies. There is this company Replit, which does coding tools. They want to iterate with programmers to have minimal input in creating software. There's also actually big technology. They use reinforcement learning, but I think it's a little bit related. So you can find resources using the papers and so on. And shortly, do I think we will get to the AGI and what impact will it on society? I think I'm not sure. Like if we can get there, it's we are obviously improving the results, and this will have a huge impact. Can there be another AI winter? I think I wouldn't dismiss that completely. It's very easy to live in the bubble that everything is working great. And what will be the impact on society? So here I think that people actually, now there are so many easy problems that they are not that challenged. And I think people have huge abilities that they can achieve much greater things if they are required to. And so that will be all from me. Thank you very much. Any questions? Yes.
Thank you. What specifically do you use or do in Line? This was theoretical, so I would like to know what does more
this is theoretical. We do use transformer architecture, right? Because we have vision and language problems, so we use both. There is this collab notebook where maybe you can see what maybe a little bit of example, and we have several things that we solve. It's the recommendation. That's very different. It's pretty much like a very much symbolic approach, I would say, because there's it's very different sort of problem, and it naturally is more less neural networks and more like scalable approaches, like symbolic. And yes, we also do similarity between the products with images and search. Yes.
Did you find anything that didn't work? Like, did you wanted to apply this?
Yes. Well, it's in the industry, it's a lot about the cost. Like you have to think about is it how fast can I develop this? How expensive is it going to be? And I think it's great. In the previous presentations, it was very much mentioned. So yeah, it usually doesn't work. It can be many scenarios, and it's a lot about the cost. Like you can get the huge super performant model, but if you cannot pay for it with what it's doing, then you cannot use it. But yeah, the hardware is getting cheaper, so it's going to be more and more moving forward. Other questions? Okay, we also have the questions from the Slido, right?
But I think there is not a single question.
Okay, so Slido.
Now you should ask the question, guys.
I can open the Slido. Okay, just say if you want to ask Slido, you can anonymously, you don't have to send
Is anybody willing to ask any question on the Slido? No? Okay.
So, yeah, thank you.
So thank you guys for coming. Hope you all enjoy it. Thanks once again to our speakers. And now it's time for networking. If you want to grab any beer or snack, whatever, what's left there, be free to do that. Thanks once again.